Today we are going to be doing 7th grade math, chapter 4, lesson 1. We're going to be talking about terminating and repeating decimals. Now, the first thing we need to note is what is a terminating decimal versus what is a repeating decimal. The easy way to remember this is a terminating decimal is a decimal that terminates, like 0.1 or 0.5. 0.735, something like that. A repeating decimal is something that has a part of its decimal that repeats. For example, let's take something like 1/3 and turn that into a decimal. Now, in order to turn a fraction into a decimal, we need to divide numerator, which is the top number, by denominator, which is the bottom number. This will be 1 divided by 3. 3 cannot go into 1, so we're going to put a 0. We're going to put a decimal, and we're going to annex a 0. 3 will go into 10 3 times. That will equal 9. When I subtract, I have 1 left over. Now that I have a decimal in place, I can bring as many zeros as I want. So I'm going to bring down another 0 since 3 cannot go into 1. 3 goes into 10 3 times, which will be 9. When I subtract, I will have 1. Then I bring down another 0. 3 goes into 10 3 times. That'll be 9. When I subtract, I'll get 1. And then it'll keep going and going and going. This is a repeating decimal. If I were to put this in a calculator, it would be 0.333333 forever. So 1 divided by 3. And in a calculator, it'll just say 0.333333. And instead of writing all of this out, 1/3 will be written as 0.3 with a line over what repeats. That right there, that line, is known as bar notation. Bar notation indicates what part of a fraction repeats. Now, bar notation does not need to just be over one number. For example, here we have a decimal, 11.385. If we were to put this in our calculator, whatever the division was, it's going to be 11.3858585858585 forever and ever and ever. Notice that the line is only over the 85, which means that is the only part that repeats. The bar notation is going to be over the number or numbers that continue to show up. It can be a pattern of 2, 3, 4, 5, whatever amount of decimals that repeat. But if it's a section that repeats over and over, that is where the bar notation goes. So again, the difference between a terminating decimal and a repeating decimal. Terminating decimal will not have bar notation. It's a decimal that ends. A repeating decimal will have something like this, where it continues to repeat and repeat and repeat, and instead of writing it out forever, we put the line, which is known as bar notation, over the part that repeats. Terminating decimal will not have bar notation. A repeating decimal will have a bar notation, indicating a part that repeats. Our other vocab, well, that's it. Repeating decimal, bar notation, and terminating decimal. Let's look at our notes for today. So remember, we're dealing with fractions when it comes to terminating and repeating decimals, because we're going to work on turning fractions into decimals. Again, in order to turn a fraction into a decimal, it's dividing numerator by denominator, as indicated here. Terminating decimal is a decimal that doesn't repeat. It seems to terminate or die, so it stops. A repeating decimal is a decimal that continues and never stops. It will continuously go on. And then again, bar notation is the line that is put over only the repeating digit or digits of that decimal. So the example of 1/3 being 0.3333 forever, the bar notation is only over the 3. In the example I gave here, where we have 11.38585858585, the bar notation will only go over the 8 and the 5, which is what's repeating. Bar notation will not go over the 3. The only time bar notation would go over the 3 if it was 11.385385385. Bar notation will go over the numbers that are repeating. Write fractions as decimals. So the other part of the lesson we need to talk about is place value. When we say 7/10, it means 7/10. If I say 19/100, that's the same thing as saying, I'll go ahead and erase this so we have room to write on here. 19/100 would be 19/100. Now let's erase this and actually write the chart out. So we said 7/10, which was the example they gave us, 7/10, and the decimal was 0.7. 7 in the 10th spot, 7/10. The next example that was given to us was 19/100, 19/100. The last part of the number should be in the 100th spot, which should just end up like this, because the 1 is in the 10th spot, then it goes to hundreds. So this is 19/100. Then they want us to do 105 thousandths. So we're going to erase this. As a fraction, this is going to be 105 over 1,000. In place value, after the decimal, we have the tenths, then the hundredths, and then the thousandths. Thousandths. Nope, don't want that. There we go. So, in this case, since the 1 will be in the tenths, the 0 will be in the hundreds, the 5 will be in the thousands, it'll just be 0.105, which means 105, read the place value, thousandths. So it's very important that we remember our place value. There's no ones after a decimal because it's not a whole. So it's going to go to tenths, hundredths, and thousandths. And then this way forward, it'd be ones, tens, hundreds, thousands, 10,000s, and things like that. So, quick practice. If I say I want to write 8 hundredths, it'll be 8/100. And then as a decimal, it would need to be 8 in the 100 spot. If I write this, this is 8/10. 8 is in the 10th spot. I would need to add a 0 and put 8 in the 100th spot. This is 8 hundredths. If I were to take my calculator and divide 8 by 100, I will come up with 0.08. 8 divided by 100 gives me 0.08. That's 8 in the 100th spot. Now let's switch it up. If I want 8 thousandths, I would need to add another 0 and make sure that 8 is in the thousandths spot. And if I were to divide this again, calculator, 8 divided by 1,000, I will get 0.008. So place value is going to be very important when it comes to this. So again, we're learning how to, or reviewing, I should say, how to turn fractions into decimals. If the denominator of a fraction is a factor of 10, 100, 1,000, or any greater net power of 10, you can use mental math and place value. What we just did is only when you have tens, hundreds, thousands, 10,000, so on, as the denominator. If it's something different, like say I have 2/5. If you can change the denominator to be one of those, for example, I can change 5 to become 10 if I multiply it by 2. 5 times 2 would equal 10, which means I need to do the same thing up here. So this would be 4/10, or 0.4. That's one thing you can do. You can convert to it to be a 10, 100, 1,000, 10,000, whatever. But say we have something where it can't convert. Let's say my example fraction is 3/7. I can't turn that 7 into a 10 or 100 or 1,000 because 7 will not convert up into that. Now, in order to turn 3/7 into into a decimal, I have to divide. I'm going to use my calculator for this one. So 3 divided by 7 results in a gigantic number. Now, this is going to be a repeating decimal. Now, let's get our black pen out, and let's split screen this. Got the calculator there, and we're going to erase this. So 3/7 becomes 0.42857142857142. So we have ourselves a pattern here. 0.4285714285714287. So everything repeats up to the 1. So our answer in this case of 3/7 would be 0.428571 with a bar notation over 428571, since it continues and continues to repeat. You'll notice here on the calculator that last number is a 3. The reason why that is because they round up the 2 to 3 just to kind of help give it an end, but ignore that. You're going to look at exactly specifically what is repeating. 428571, 428571, 428571. That is repeating. The bar notation will be all over that. All right, moving on in the lesson. So we have a few numbers here. How to convert fractions into decimals. 3/10 is the same thing as saying 3 in the 10th spot. So that one we can do mentally. 3 over 10 is 3/10 or 0.3. 3 in the 10th spot. 3/25, not as easy, but I know I can convert that 25 to become 100. 3/25, let me erase this work that we just did, and we're going to move this over. If I multiply 25 by 4, I know that it will become 100. And then I can easily write a decimal because in the 100 spot, it will end on the second digit. 3 times 4 will become 12. So 3/25 becomes 12 hundredths, or just 0.12. Now, this last one is a mixed number, and that's something that we're going to go over now in review. This is -6.5. So, in order to change a fraction into a decimal, we need to make sure that it is an actual fraction. This one, we do 2 ways. We can turn this into an improper fraction and then divide, which is going to be a lot more work, but I'm going to remind you now how to do this. So remember, if we want to turn a mixed number into an improper fraction, we take the whole number, multiply it by the denominator, add it to the numerator. This would be 6 times 2, which is 12, plus 1 would be 13 over 2, and since this is negative, it'll be -13 over 2. The other way we can do this, since we don't need to necessarily convert it into an improper fraction, is the following. We are converting this mixed number into a decimal. This is a whole number. A whole number in a decimal is just going to be the first part of it. So it's going to be -6 point something. Now, 1/2, we should all know, is 0.5. If you don't know that, you can actually convert this to become 10. 2 times 5 is 10. 5 times 1 is 5. 5/10, or 0.5. So my answer should be -6.5. -6 and 1/2 is the same thing as saying -6.5. All right, and then the rest of the lesson is going to be talking about writing fractions as decimals. I understand we have calculators, but we really need to be able to do this longhand. So we're going to do 3/8 as a decimal together. So let's pull up a new whiteboard. And again, it was 3/8. Now, we can put this in a calculator to make it easy, or we can do this. 3 divided by 8. 8 will not go into 3, so it'll be a 0 with a decimal. We annex zeros. Now, counting by 8s, I know that 8 will go into 33 times, which will be 24. When I subtract 24 from 30, I'll end up with 6. Now, 8 cannot go into 6, so I need to bring down a 0. Now, I know that 8 cannot go into 60 evenly, so I'm going to guess and check here. And knowing my 8s, I know that 8 times 7 is 56. If I add 8 more to it, it's going to be definitely over. So it's going to be 7. 56. When I subtract, I'll have 4 left over. 8 cannot go into 4. Bring down a 0. 8 goes into 40 5 times, which is exactly 40. And that's it. So 3/8 is equal to 0.375. This is a terminating decimal. As you see, it ended here. In the example I gave earlier in the video, we just kept dividing 10 by 3, and then 10 by 3, and 10 by 3, and keep going and keep going. This ends with a 0 at the end. If we look here, 3/8 is 0.375. And they give another example of -1 over 40. 1 divided by 40 would end up in being 0.025. It terminates, but because of the negatives there, we bring the negative back over. And then 7/9 would end up in, 63. How many times can 9 go into 63? It'll be 7. 9 goes into 63 again, 7 times. 9 goes into 63, 7 times. Keeps going, keeps going, keeps going. And that will be a repeating decimal of 0.77777, or just 0.7 bar notation over the 7. Whew. All right. Writing decimals as fractions. Let's go ahead and do some of these godets. We'll write decimals as fractions, and then we will call this a lesson. So we are going to go ahead and do D through G. -7/8. We're going to ignore the negative, but we know that the negative is going to come back in the answer. So in order to convert -7/8, we're going to do 7 divided by 8. 8 cannot go into 7, 0. Annex a 0. 70 divided by 8. Now, I know, again, my 8s are rough, but I know 8 times 8 is 64, and I can't add any more 8s to that because it'll go over. So it'll go 8 times 64. When I subtract, I'll have 6 left over. 8 cannot go into 6, so we bring down a 0. Now, we knew that 8 times 8 was 64, so it's going to have to be less than that. 8 times 7 is 56, so it'll be 7. 56. When I subtract, I'll get 4 left over, and then we're back to what we were before with 8 going into 45 times. Terminating decimal, so 7/8 is the same thing as saying 0.875. And that's how we solve that one. Next question. Let's go to E. 2 and 1/8. Now remember, when we have a mixed number and we're converting it into a decimal, the whole number is just going to move over. Oh, wait. I messed up on that last one. That should have been negative 0.875 because I forgot to bring over the negative symbol right there. If it will let me draw. That negative symbol right there, it won't let me draw. So we're going to ignore it right now. All right, so 2 and 1/8. The 2 is going to be brought over, and the 1/8 is going to be the part that we are going to bring in as our decimal. That means 1 divided by 8. It's all these 8s, man. 8 cannot go into 1, annex is 0. 8 can go into 10 twice. That will be 8. Sorry, twice. Wow. Once. That will be 8, and that will be 2. Dyslexic moment. 8 cannot go into 2, bring down a 0. 8 can go into 20 twice, which will be 16. I will get 4 left over, and this 4 is our friend here. 8 will go into 45 times. Terminating decimal. So 2 and 1/8 will be the same thing as saying 2.125. Wasn't a negative, so there's no negative in it, like I messed up on the last one. And we have -3/11. Now, let's remember our decimal is going to start with a negative. -3/11. So this is going to be the same thing as saying 3 divided by 11. 11 cannot go into 3, 0, annex is 0. 11 will go into 30 twice. That'll be 22. I will get 8 left over. 11 cannot go into 8, bring down a 0. 11 will go into 87 times, which will be 77. Then I'll have 3, bring down a 0. 11 will go into 30 twice. That will be 22. Subtract, I'll have 8 left over. Bring down a 0. That will go in 7 times, and so on and so on. So we see the repeat of 27, 27, 27. -3/11 will be negative. I brought down the negative this time. 0.27. Bar notation over the 2 and the 7, because that repeats. All right, and the last one of these examples, we have 8 and 1/3. It is positive, so we're going to have 8 in our answer, decimal. Now, if we have a shortcut and we remember what fractions are, we can go ahead and just utilize that and not have to do the math. I know 1/3 is the same thing as saying 0.3333333 forever, because we did this as an example earlier. 1 divided by 3 equals 0.3333333 forever. Therefore, this will be 8.3 bar notation over the 3. So if you remember certain fractions as their decimals, totally allowed to use that. That's like remembering 1/2 is 0.5, 1/4 is 0.25, 3/4 is 0.75. Those shortcuts are totally allowed if you remember them. And 1/3 will be 0.33333 forever. My computer's fan is kicking on, which is telling us that we need to wrap up. So let's go into the last part of the lesson, which is pretty easy. Every terminating decimal can be written as a fraction with a denominator of 10, 100, and 1000 or greater power of 10. Use the place value to find the digit as the denominator. Now, this is very important to add to your notes. Every terminating decimal can be written as a fraction with a denominator of 10, 100, 1000, or a greater power of 10. If it's a repeating decimal, cannot happen. Will not happen. So, the fraction or the decimal here is 0.15. We're going to put this as 15 over and its place value. Starting from the decimal, we have 1 in the tenths and 5 in the hundredths. Therefore, it'll be 15 hundredths. That's how we write that place value. So, we're going to look at these numbers and write them as their place value, if OneNote will let me draw. So let's see. We're going to pick a different color pen today. Let's do black, and let's see. And it works. So let's go ahead and get the eraser out really quick. Oh, guess I don't have the eraser. There we go. So 0.4. We are looking at the last number in the place value. Since there's only one that's 4 in the 10th spot, that'll be written as 4/10. The 15 in the 100th spot was 1500ths, as we did earlier. Got it. This is 25, and the 5 is in the hundreds, so it'll be 25 over 100. And this is 0.2. 2 is in the 10th spot, so it's 2/10. That's pretty much it. Now, looking at the got it's, determine the fraction of the aquarium made up by each. Oh. Well, we already did that. Never mind, we already did that. we acknowledged that angelfish make up 4/10 of it, the goldfish make up 15/100ths of it, guppy makes 25/100ths, or if we make this smaller, it's a 3/4. The 15/100ths both can be divided by 5 on that one. So that would be, let me see, 100 divided by 5, that would be 3/20ths. If we were to divide both numbers by 5. And then the mollies make up 2/10, or if we divide both of them by 2, 1/5 of the tank. And then over here we could divide both of them by 2, and that would be 2/5 of the tank. Simplifying fractions. And that's basically the lesson. So remember to have, when it comes to terminating decimals, those are decimals that stop or end. So we'll review our notes here. Decimals that stop or end are terminating decimals. A number that has a section that continues to repeat is a repeating decimal. A repeating decimal is acknowledged, or what's the word I would use? Not acknowledged, but indicated is a better word, by a bar notation. The bar notation is the line drawn over the digit or digits that continue to repeat. And then other notes we had, these are reviews, are the placement values, the place values of decimals. So remember, after a decimal, it's tenths, then hundredths, thousandths, 10,000ths, 100,000ths. And we can write any decimal as a fraction by the last number being put over its place value. But those are only for terminating decimals. Any repeating decimals cannot be written as a fraction that way. So that is our review for Chapter 4, Lesson 1. Any questions, comments, concerns, again, if you're in my class, you can reach out to me via Teams, email, in class. If you're not in my class and you're watching this as supplemental, please feel free to leave a comment if you have any questions, and I will get back to you as soon as I can. As always, this is Mr. P signing off. Have a good one.